So let's look at factoring a special kind of trinomial called perfect square trinomials. What is a perfect square trinomial? I think we may have talked about this, but anyway, a perfect square trinomial is one that can be factored as the quantity a plus b to the second power, or a plus b times a plus b. So notice the two binomials, when you factor them, are exactly the same. That's what happens with a perfect square trinomial. So this is an example that will make a perfect square trinomial. If you multiply x plus 5 times x plus 5, that will give you a perfect square trinomial. So if you multiply this out, x plus 5 to the second, that means x plus 5 times x plus 5, combine like terms, and you get x squared plus 10x plus 25. So that right there is an example of a perfect square trinomial, because you were able to multiply the binomial times itself to get that. Look at the c term. C term is 25. Look at the a term. A term is 1 because it says x squared. Can you take the square root of x squared? Yes, the square root of x squared is x. Can you take the square root of 25? Yes, the square root of 25 is 5. Well, now what do you notice? If you multiply x times 5 and then multiply it by 2, what do you get? X times 5 is 5x, 5x times 2 is 10x. And what's interesting about the 10x? Look right there. 10x represents the middle term. That will always happen with perfect square trinomials. So, using that concept, let's look at this and determine if it is a perfect square trinomial. If it is, that means I should be able to multiply one binomial times itself and get this. Well, what did we just talk about? We said look at the first term, like on this one. We said look at the x squared. Can you take the square root of it? Yes, it's x. Can you take the square root of 25? Yes, it's 5. That's the first step with always looking at perfect square trinomials. Can you take the square root of the first term and the square root of the last term? So the square root of x squared is x. The square root of 16, yes, that's a perfect square, so the square root of 16 is 4. Well, the last step, in order to determine if this is a perfect square trinomial, now double it, just like we did before. And what's 4 times 2? 4 times 2 is 8. 8 times x is 8x. That matches the plus 8x in the middle. So we know then that the factorization of this is going to be the square root of the first term, which is x, plus the square root of the second term, which is 4. And if I multiply those two binomials together, it's going to give us 8x squared plus 8x plus 16. So yes, this is a perfect square trinomial. What about this one? I see a minus sign here, so does that automatically make this a no? Well, we still want to check. Look at the first term, x squared. Can you take the square root of that? Yes, the square root of x squared is x. So that makes me think, alright, think back to what you've been doing before with factoring trinomials. If this is positive, and if the middle term is negative, that means you can factor 9 by multiplying negative 3 times negative 3. So since this number is negative in the middle, we want to think of 9 as being the product of negative 3 times negative 3. Well, what did we do before? On the one before, we remember we took the square root of x squared, we took the square root of 16, but then we had to double it to see if it matches the middle term. So that's what we're going to do here. We now want to double this, and what's negative 3 times 2? Negative 6. Negative 6 times x gives you the negative 6x in the middle. So yes, this would be a perfect square trinomial. And the factorization of that, we easily know then, is going to be this term, the square root of x squared. And now since this is negative, it's going to be minus the square root of 9, which is 3. And if you square x minus 3, you will get x squared minus 6x plus 9. Alright? What about this one? Is x squared a perfect square? Yes, you can take the square root of that. Is 49 a perfect square? Yes, you can take the square root of that. So far, it's looking good. But now remember, we've got to double it. When we double it, what do we get? We get 14x. But what's the middle term? The middle term is 7x. So they don't match. This would be an example of a trinomial that is not a perfect square trinomial, so we would not be able to factor this as x plus 7 times x plus 7, because it would not give us a middle term of 7x. What about this one? What are you thinking? You see the coefficient of 9. Does that automatically mean that's not a perfect square? Can you take the square root of this first term? 9 times n to the second power. Well, yes you can. What's the square root of 9? 3. What's the square root of n squared? N. So, yeah, you don't have to have a coefficient of 1. Your a value here can be any number as long as it's a perfect square. So the square root of 9n squared is 3n, and now I notice I have a minus here in the middle, so that's making me think I want this factor of 25 to be negative. Is 25 a perfect square? Yeah, the square root of 25, in this case we'll call negative 5 since the middle term is negative. So here's the square root of the first term, here's the square root of the last term. Well, if this is a perfect square trinomial, remember we've got to double it. Well, 2 times negative 5 is negative 10. Negative 10 times 3n gives you negative 30n, which matches the negative 30n here. So yes, this is a perfect square trinomial, and if I want to factor it, it's just going to be 3n minus 5 and then square it. 3n minus 5 times 3n minus 5 would give us this perfect square trinomial. So this is an easy way to factor. You don't have to think about all the different possibilities of factors of 9, all the different possibilities of factors of 25. If it's a perfect square, you automatically know your first term is going to be the square root of this, and your second term is going to be the square root of your c term. Alright? What if you had this? What if you were given this trinomial, 25x squared plus bx plus 16, and it's asking us, in order for this to be a perfect square trinomial, what would be the value of the variable b? Well, remember, if it's a perfect square trinomial, what do you know here? You know that this has to be a perfect square, and can you take the square root of 25x squared? Yes. 5x times 5x is 25x squared. Can you take the square root of 16? The square root of 16 is 4. So far, this is making this perfect square. Well, remember, to get your b value, it's not just 5x times 4. Remember, we've always got to double it. So 5x times 4 is 20x. 20x times 2 equals 40x. So we know that the b value is going to have to be 40. So if b is 40, it will make this a perfect square trinomial. And what would be the factorization? So if I make b 40, this is going to become 25x squared plus 40x plus 16, and the factorization would be the square root of 25x squared, which is 5x, plus the square root of 16, which is 4. And we know easily that that would be the factorization for this perfect square trinomial. Alright, look at this one. I think this might be the last one. So now we've got this, and we have our b value, and we want to know what would have to be the value of b in order to make this a perfect square trinomial. All right, well, take the square root of 100n squared. What's the square root of 100n squared? It's 10n. Notice we have a minus here, so I want to be thinking about the factors of 4 as being two negative numbers. 4 is a perfect square, so the square root of 4 would be, in this case, negative 2, because we want our b value to be negative. So we multiply the square root of the first term times the square root of the last term, or the c value, and then we have to double it, and that will give us our b value. So 10 times negative 2 is negative 20. Negative 20 times 2 is negative 40. So we know then that when this middle term is negative 40n, it'll give us a perfect square trinomial. So the b value would have to be 40 minus 40. So b would be 40. And then the factorization, now that we've got 100n squared minus 40n plus 4, the factorization of this, we easily know, would be 100n squared. Square root of 100 is 10n. Square root of 4 is negative 2. So that would be 10n minus 2 to the second power. Now, are any of you thinking about what you've done for the last few days? Is this the complete factorization of 100n squared minus 40n plus 4? Let's look at that for 1 second. 100n squared minus, what was it, 40n plus 4. Alright, so we already determined this is perfect square, so it can definitely be 10n minus 2 squared. But what did we talk about yesterday? We talked about how you have to look at the terms and determine if there's a GCF. Can you factor out a GCF from this? Don't these all have factors of 4? So you could first factor out 4, and that gives you 25n squared. Factor out 4 here, you get minus 10n, and then factor out 4 here, and you get 1. So by factoring out 4, you get this trinomial, 25n squared minus 10n plus 1. And so if I want to think about this as being a perfect square trinomial, I want to check it and see if it is. What's the square root of 25n squared? 5n. What's the square root of 1, knowing that it's got to be negative here? It would be negative 1, because negative 1 times negative 1 gives you 1. Remember, you've got to double it. And when you double this, what do you get? You get 5n minus 1 is negative 5n. Negative 5n times 2 is negative 10n, and that matches the middle term. So we still have a perfect square trinomial. It's just one with 4 factored out. So if I wanted to factor this, it would be 4 times square root of 25n squared is 5n, or you can just look over here, square root of 1 in this case needs to be minus 1, so the factorization would be 4 times 5n minus 1 to the second power. Alright, so you're going to see this in your textbooks when you get into high school. You'll see this format. So if you've got perfect square trinomials, meaning a plus b times a plus b, your trinomial is always going to just be the square of a, your c term is going to be the square of b, and then the middle term is just going to be the double the product of a and b. That should look familiar to what you were just talking about. Or if it's a minus b, the first term is going to be a squared, the last term is going to be b squared, and then the middle term is just going to be 2 times the product of a and negative b, which would be negative 2ab. So this should help you with the problems that you're going to be doing today. Let me know if you have questions.